So we're going to be starting the last chapter on the statistics book, which is on hypothesis testing. So for this, we're going to need to know a bit about the binomial distribution, which we've already covered this year. For the prior knowledge check, they ask you about binomial distribution. I'm going to do this as a separate YouTube video for you to have a look through to make sure you can just get to grips with the calculator skills that we need again, because it's one of the functions in our calculator. But outside of this, look at the language and concept of hypothesis testing. So what is it? Understand a sample is used to make an inference about a population. So essentially, if we want to test to see if something's true or not, we can't, for reasons that we've already discussed in statistics, just go and ask everybody in the population. It's too time consuming, it's going to cost too much money. Therefore, we're going to take a sample to make an inference about the population. We're going to have a look to see how we'd find critical values. So values at which we would say we're right or wrong about our hypothesis. Carried out a one-tailed test for the proportion of binomial distribution. So we're going to link this into the binomial distribution or hypothesis testing. When we get to year 2, we look to see if we can use other distributions as well. But for this one in year 1, we're just having a look at the binomial and then a two-tailed test. And I'll explain a bit more about what those things are a bit later. So just to start off, a hypothesis is a statement made about the value of a population parameter. So basically something that we can measure to do with that population. So we can either carry out an experiment or we can take a sample from the population to see how those results work. And again, we're going to be tying this into the binomial distribution for this whole chapter here. The result of the experiment is calculated from the sample, is called the test statistic. But we need to form two hypotheses. So if we do science, or we might have done some statistics previously further down the school, typically we only just work with one hypothesis. Like, my hypothesis is that this is true. Now, for mathematical testing, and for this to be considered more reliable, we're going to work on the fact that we're going to have two tests, or two hypotheses. Now, the first one is going to be called the null hypothesis, which we can call H0. The null hypothesis is the one that we're going to go in to this test assuming is correct. Assuming it's correct, and typically it's going to be what's there already. Typically it's going to be what we think we know already about this test, or about the population, about the parameter that we're testing. The alternative hypothesis, which we can call H1 here, tells me about the parameter if the assumption that I've made is shown to be wrong. Now, often what we're trying to do with the sort of statistical testing that we're doing in year 1 is saying, well, this is the way it is, and this is the way it has been up to now. However, we've had some new data and we want to see if that's changed our assumptions made. Does the new data in about the new sample that I've taken change how I should be calculating with these values about this parameter? Okay, so for instance, we might be going along on one assumption about a dice being non-biased, and then I keep rolling that dice over and over again. I notice there are patterns, and I want to know, actually, are the patterns that I'm seeing, the results that I'm seeing, indicative of this dice not being as I thought it to be? So we're going to be testing using mathematics whether this actually is a significant result, or whether that could be something that can just be explained by coincidence. Okay, so we're going to go through example 1 as a YouTube video, and we'll see where we go from there.